tool for generation, transmission, distribution, and industrial network. DIgSILENT has set a standard trend more than 25 years. The proven advanced and the PowerFactory softwares are it overall functional integrated with its application in the field of power transmission, power distribution, industrial systems, power generation, distribution generations, and we also have two and PV systems collaborated in the system. Basically stands for Digital Simulator for Electrical Network. Software development began in 1976, and that time it was first simulation software available in the market. The development work began with the DIgSILENT version, previous versions. Now we are using 15.2.6 version till the date, and with the coming new year, they are standardizing to its 2006. With the start of 2016, they are providing us with the 16th version of the software. So the DIgSILENT PowerFactory software integrated with some basic definition tools and analyzing tools combined with reliable, flexible modeling capabilities, state-of-art solution algorithms are there, and unique database concept management is available in the software. So PowerFactory includes load flow analysis, short circuit analysis, contingency work reduction capabilities and test we can conduct, techno-economical analysis including some voltage stability analysis also, load flow sensitivity test we can conduct, overhead and line cable parameter calculations, those kind of calculations can also be conducted. Basic MV and LV network analysis can be done. Asynchronous machine parameter identification we can just give it to our generation part of the system. So now we will see the detailed analysis functions which we can do in this DIgSILENT PowerFactory software. In load flow analysis, we can analyze balanced and unbalanced load flow for coupled AC or DC grids, mesh DC super grids. Load flow analysis can be conducted. SVC, shunt and tap controllers are present. Station and network controlling features, different input modes like cos, VIS and Q and group characteristics can be conducted. Local and remote controlling options are present in the software. Consideration of generation capabilities curves with the help of secondary and primary controlling. Initial response can be generated. Distributive slack by load and generation, including grid interchanging schedules can be done. Accurate modeling of induction machines. Voltage dependent load models are there. Simple load generation scaling as well as automated feeder load scaling can be that kind of test can be conducted. Determination of a risk or at risk can be done. Consideration of temperature dependency. DPL scripting for time shifts, ATC and penalty factor calculation can be done. DPL generally stands for DIgSILENT programming language, where we can write our program and give automated scripting through the network, and also provide dynamic inputs to the appliances which we using in our PowerFactory network. So these are some basic features and the part of analysis we can conduct on load flow analysis. Now it's contingency analysis. AC and DC and combined AC-DC load flow analysis related to contingency cases can be conducted. Fast contingency screenings are there. Single and multiple time phase considerations. Event-based post-fault actions can be conducted. Substations automation via switching schemes can be done. Automatic time shift contingency analysis for 24 hours of time span, including parallelization. Like we can just analyze contingency sweep analysis or contingency analysis on two of the part of the system on our network, and analyze it for 24 hours like that. Generator effectiveness and quad booster effectiveness can be also analyzed. Enhanced fault cases management characteristics can be given to the system. tracing of individual contingency cases while designing any network in power system. We can trace step by step to the systems like contingency, post contingency events we can create, and also contingency comparison modes are there, which includes CPU computing support and grid and multiple computings. So these are some contingency analysis functions and features which including in this software, and we can conduct it. I will show you more when I will work on the software. Network reduction. We have flexible definition boundaries for reducing our network to a most reliable network. Calculation of load flow, short circuit equivalents are present. Support of load, watt and extended watt equivalents can be generated. Capturing of reduction via variation, convenient toggling between original and equivalent grids can be provided to the system. So based upon that, we can reduce our network to most reliable part and more stable part while using this network reduction features present in this software. So these are some network reduction functions which we have in this software. Now short circuit analysis. The software supports all the standard norms including IC, IEEE, ANSI, VD, and IC different norms, while like 60909 and slowly circuiting. Complete superposition methods including of generation correction via power electronic equipment can be possible. Multiple fault analysis of any kind fault including single phase interruptions and also in inter-circuit faults can be generated. So in short circuit analysis, some of these functions are included through which we can test our system while using short circuit analysis. In voltage stability, PV curves and QV curves analysis, the major part of the analysis to voltage stability analysis are PV and QV analysis. Load flow sensitive run voltage transformer and booster. Modern IC identify a strong and weaker part of the design any network. Hello. 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 Sorry for inconvenience caused. Some network issues are there. Then I will continue again. Techno-economical analysis includes some economical assessments of network expansion strategies, and also the network representation and value models, and also the costing of losses, minimization, investment costs, and economic impact failure rates throughout any particular section or throughout all the system in our network, and also analyzing the effective ratios and determining the cost of investment, which will for 1 year period of time, like optimal year of investment on a particular section. So that kind of calculations we usually do in techno-economical analysis, and also schedule the projects like that. Project wise we can schedule our investment and can give fixed particular times for a network expansion strategies to any of the sections. That kind of calculations we can do in techno-economical analysis. So these are some basic features which we can conduct on techno-economical calculations. Basic MV and LV network analysis includes feeder analysis tools, including voltage profile plots and feeder load scaling for simple or meshed feeders, automated systematic visualization of feeders topology is present in this software. Radial feeder technologies like different tools of voltage and phase technologies, change tools, and auto balancing tools are present. Backbone calculation determining main connections between meshed and feeder, we can give it. LV network analysis functions are present in this software. Stochastic load modelings, like we have in our database of different libraries, which this software puzzle, in which we have different stochastic load models present already in this libraries. So you can take from there also and just analyze your system on the basis of the test you are going to conduct, like its MV or LV network. So these are some features which include in basic MV and LV networks analysis functions. Power equipment tools, including large and comprehensive equipment type libraries, and also synchronous and asynchronous machines, motor generators, double fed induction machines, static generators for modeling wind and PV systems. We have PV and wind turbines for analysis in this system. Complex studies for integration of wind generations into distribution and transmission networks have become very important nowadays. So for that, PowerFactory gives you standard wind generation modeling capabilities, and also combine extensive modeling capabilities with advanced solution algorithms, thereby providing an analyst with the tools undertaking the full range of studies required for the grid connections, and also a grid impact analysis, in which we can calculate the short circuit calculations with the optional inclusion of dynamic voltage support according to K factor settings on wind turbine, power quality assessment according to IC standards, stability and EMT analysis in wind turbines, methods for establishing generator and converter types, additional wind power plant equipment such as control and shunt statcoms are present. Stochastic wind models for generation and adequate studies are available. So these are some wind turbine features, wind generation features which we have in this software. Also have PV generation, PV systems we can just including fuel cells, micro turbines, and a lot more type of generations this software possesses. External grids like AC and DC voltage and current sources are present. Simple and complex load models, special MV and LV load models are present. Static VAR compensators and shunt filter models are present in the software library. Static VAR compensator are variable compensator in the line which we connect through equipment to the line section is present. Network branches like cable branches, line couplings, tower geometries, cable systems, So all the basic appliances which we need to design any network or to create any network are present. DC-DC converters are there, inductive DC couplings are there. For electronic devices, thyristor diodes, DC valves, soft starters are present. We have FACTS and HVDC systems can be analyzed. Controller objects such as station and secondary controller, transformer tap controller, virtual power plant we can create. Capability curves based upon that we can just design. Protection devices libraries like static and dynamic functions based devices are present. Fourier sources and harmonic sources are also present, and including FFT, clock, SNH, etc. are present. Parameter characteristics based upon scalar vector matrix files can be given to the system, and based upon that we can analyze our modules or do analysis based upon that. Grid organization and element grouping, like we have to define zones, areas, boundary circuits, routes, and different feeders. So that kind of organization, creating an organized manner of zones, areas, we can define in this system. So these are some power quality equipment modules which we have in this software. In network representation, we have support both kind of network, either it is meshed or radial, 1, 2, or 3 or 4 wire AC and DC networks with combined AC and DC modeling capabilities. Available analysis functions are present in this software. Single phase, two phase, biphase, three phase technology with neutrals can be analyzed. Detailed primary and secondary substation models with single and double bus bar with the tie breakers and bypass bus bars are available. Extendable user specific bus bar configurations can be done, including protection schemes. We can just create our CTVT or relays and place on our networks. Switches, substation equipments like circuit breaker, fuser, disconnectors, load break switch, grounding switch, NEC, NER, surge arresters, and CTVT, CVT are all the equipments which we need to protect our network are present. Running arrangement and switching rules for substation automation can be provided in network representation function. So these are some network representation features which we have in this software. PowerFactory advanced functions include protection functions, cable sizing functions, distribution network functions, power quality and harmonic analysis we can conduct on that. Arc flash analysis, reliability analysis functions are there. Optimal power flow studies we can conduct. Stability analysis functions related to root mean square simulations we can do. Electromagnetic transient calculations, based upon that we can conduct. Small signal stability eigenvalue analysis we can do. State estimation, motor starting functions, scripting automation, and also includes the GIS and SCADA integration to the system. GIS and SCADA can be integrated to the system with the help of OPC. OPC is just a platform which can be work as an emulation part and create a network between software and hardware. So this software can be connect with the hardware systems for real-time analysis. This kind of simulation they are doing in IIT Kanpur. They have RTDS lab, real-time digital simulation lab. They just connected this system, this software with the hardware system and analyzing all the functions there. So that can be possible to connect the software with the hardware part of the system. Protection functions including like relays library, different relays frames, relays models with the company standard and specifications are present. We just have to click and select our desired relays. Suitable for both steady and steady state, RMS and AMT calculations. Synchronization with stationware is possible with the software. Elaborated relay setting, spreadsheet reporting can be done through elongated protection functions which software providing. In load flow transmission, fast and accurate load flow algorithms connected with the Newton-Raphson and Newton-Raphson current iterations. Based upon that, we can collect our data from load flow transmissions. AC and DC, both networks can be analyzed. Secondary power factor controlling schemes are there. Primary controlling features are present in the software. Secondary reactive power voltage controls facilities are there. Load profiling, we can generate our PV curves throughout the load flow. Also, types of sensitivity like dV by dQ, dpH by dP, branch sensitivity test, and model analysis based upon dV by dQ. We can do it in load flow analysis. In load flow distribution, any kind of network topology like three-phase 4-wire, two-phase, biphase, single-phase or through-return, and also DC network combined we can do. Any type of network topology, it is meshed or radial, or we can do it with the both. Suited for extremely large MV networks, more than 20,000 bus bars can be analyzed. The software comes with the two parts. One is the educational version and one is research version. In research version, there is no limitation, so we can analyze our network to more than 20,000 bus bars. So voltage profiling diagrams related to our load flow we can obtain. Stochastic load models for considering load diversity in LV networks can be generated. 1 and 2 dimensional load profiling, including feeder scaling options are there. Open point optimization is there in this software. So load flow distribution include these some features which we can conduct on this software. Active and reactive power dispatches, generally we give it to our generation part of the system. We can also give to minimize our losses, fuel cost, branch flow limitations we give, bus bar voltage limitations, active and reactive power controlling limits we can give, stator current limitations, reserve constraints. So these are some basics through which we can analyze our generation part and also control our system and the flow throughout the system. So these are some basic features, including with the dispatch of power, are present in the software. While doing stability analysis, transient and dynamic stability we can calculate. Highly accurate generation models and load models are there. Large library and standard models present already in the software. We just have to click and select, and you can just import from there and do analysis part on that. User-defined modeling capabilities are present. Variable step sizing algorithms are there. Easy to use chart definitions, interactive event definitions facilities are there. A small signal analysis, like we do model analysis functions. In stability we can conduct. So these are some stability functions. Based upon that we can just check the stability of our network or the whole system. In electromagnetic transient, detailed network models can be just analyzed. Transformer saturations, transformer capacitance, distributive parameter line models, constant and frequency dependent lines can be just analyzed. Detailed switching of power system, power electronic devices models, easy to use chart definitions with including interactive event definitions can be done. Variable step sizing algorithms are there. So in electromagnetic transient we have some of these features. In overcurrent protection we have modeling of we can do CTVT models have already present in the software, and also generate user defined fuses. We can just change the parameters, and also some company specs and standards parameters, frames and relays are there. So we just have to click and select in our desired diagram. OCT relays, direction relays, differential relays, LV circuit breakers are present. Coordination with the selective diagrams we can do it. Simulation based upon steady state and time domain both can be simulated. So in overcurrent protection we have these some features which include in the software. In distance protection we have CTVT models. MHO characteristics can be provided. Quadrilateral characteristics can be provided also. X and R ratios blinders are there. Starting characteristics, inter-tripping schemes can be provided. Coordination with the RX diagrams, time and distance diagrams can be provided. Simulation based upon steady state and time domain simulations can be just analyzed. So in distance protection, we have these features including in this software. Harmonics. In harmonics, we have balanced and unbalanced harmonic cases, characteristics and non-characteristic interharmonic cases we can just analyze. Frequency-based time domain charts can also be analyzed. Harmonic load flow calculations we can conduct through our network. Frequency scanning can be also done. Frequency dependent line parameters can be also generated. Distributed parameters line models can be analyzed through different harmonic cases. Filter sizing can also be defined through our harmonic functions. So these are some features which include in harmonic study cases and functions related to this software. In reliability test, we have Weibull Markov failure models on which we can just analyze our reliability throughout the system. Line transformer bus bar failures we can just provide to check the reliability of the system. Common model failures we can create. Double earth falls we can give it to our system. Circuit breaker failures we can just create. Protection failures throughout the system we can just analyze. Analytical state enumeration methods can be provided, including Monte Carlo simulations can be done on this software. Advanced system restoration model, including generator dispatch and load shedding facilities to check reliability functions of the network, can be provided to the system. So reliability of features, including in this software, have these some points, including advanced system restoration model, and also generation dispatch and load shedding features. I already told you that wind power have these things. Double fed induction machines, converted event synchronous machines are the HVDC light models can be network can be designed. Noise moderation can be done. Tower and blade mechanism can be provided to the wind power. Each controlling features available with the wind power. We can do it. Graphical control modelings. We can just import graph and do our calculations based upon that. That type of input can be given to the our wind power or wind turbines used in our networks. So these are some wind power and wind turbines features which include in this software. Now it's come with DIgSILENT programming language. DIgSILENT programming language is just object-oriented scripting language. Just to give commands like if, then else, do while, input output report routines. If we have to give mathematical expressions to our network, we can give it through. Execution of PowerFactory commands can be done, and PowerFactory object procedure can be also obtained from this DIgSILENT PowerFactory language. DPL subroutine calls can be also generated. So this is the programming part, a part of the system, different part of the system, and also the software is GUI based. So this is another part of the system which includes the programming. We'll have this session after I will show you the software, how it works, and how it analyzes and how it look like. So let me check system. It's just starting the software. It's taking some time. So this is the basic designing window where we design our network. These are the appliances which we use for designing our network. And this is the output window where we see the output and also check the outputs. If any error will occur to our network, it will show you here. Different simulations, which I already told you in PPT, that we can do contingency, quasi-dynamic simulations, model analysis, reliability, optimal power flow restorations. So like these, when we are doing contingency analysis, we have to just click on that and we can select our contingency definitions and contingency analysis part. So related to the analysis part, it will generate the tabs for that, for running that simulation. If you're doing harmonic, we have to select harmonic simulations. It will generate the tabs related to that. So these are the equipments. When you move your cursor, it will lead to you that what is stand for. Like these are the synchronous machine, two winding transformers, lines, loads are there. Different MV and LV loads are there, and some rectifiers, inverters, DC to DC converters, software starters are there, batteries, DC voltage sources are there. So now we'll design one network, and I will show you how it works and how we can elaborate the libraries and see the libraries. So this is a 3-bus bar system. I will show you. These are the 3 single bus bars. You can see. Just giving a generation to our small network. So you can see now it's connected. When we're going to connect any of the systems to the bus bar, you can see these models. It's basically a nodes which provide better connections to the appliances, to nodes on the bus bar without any interconnections. So in education, we just have 50 appliances can be connected to this bus bar. We can increase this size. So only 50 appliances can be connected. But in research, it can be infinite nodes, and we can connect unlimited components usually to our network. This is two winding transformer. And in last, load is connected. So when you double click on any of the appliances, it will lead you to this tab. Like you can see global types, project types, new project types. In global types, global specs of that particular appliance, like synchronous machine, with the generation like 210 megawatt MVA and 255 MVA, like that kind of global standard specifications. Based upon that, we can just select and design our and give parameter to our synchronous machine. If you work on a different projects and you have saved that data in project data in this software database, you can just select from there also in project type. New project type, we have to give these parameters. And also, like if you're doing diverse load flow, we have to give. If we're doing short circuiting, we have to give different data. So based upon our calculations, we have to give different data to our systems. So these kind of calculations, including in all the systems like global type, project type, and new project type, all the systems are having same specs and possess both the global type, project type, and including new project type where we used to feed our own data. We can connect our network with relay models. Relay models, when you select global type you can see like interactional relays, that company standards relays are there, ABB, and also frame wise different descriptions wise they are having relays. Also we can select the characteristics wise. So these are some basic standards and basic features including in our libraries. We can import to our network and can design based upon that. Now I will take you through some examples. This is my main overview of this software. So we have some basic examples based upon our distribution networks like MV distribution, LV distribution, some examples related to transmission systems, and industrial networks, wind farms, offshore wind farms, state estimation. So these are video files which make you learn how the software will work and how to conduct these tests on this software. You don't have to refer everything to the manual. You can just create here, and while you can just know how to design the network. So the LV distribution network, including like designing a base model, LV load flow, feeder load scaling, quasi-dynamic simulations, cable reinforcement. So the experiments related to LV distribution network analysis functions is available in LV networks function. Likewise, in MV distribution network, we do open point optimizations, voltage profiling characteristics we analyze, viability analysis we do, optimal remote control switching placements we do, and also techno-economic calculations we provide to our network. So these kind of networks can be analyzed. So all of them, some of them, including basic functions and also video files, video tutorials are present. So just for importing that system, you have to click like I have clicked on transmission system. I'm importing that. We can do some of the study case tests on that related to this software. It's loading. This is a 225 by 90 kV transmission system. This is an overview diagram of the system, which includes two wind farms, like wind park west is there, wind park east is there, and also some of the generators are there. Basically, this system is a hybrid one connected to the converters. And this is a single line diagram of that overview diagram, where you can see the wind farm east. Some of the generations are there, these generators. Now we will conduct transient analysis. You can see the PQI values. I just ran load flow test on this network. You can see PQI values through different section of the network. If you want to generate each and every equipment and see what is the loading there, we can also generate that kind of study cases or that kind of reportings, detailed reportings to these all systems. Just we have to click here and execute. It will provide you the detailed report of load flow test conducted on this network, where we analyze different reactive and active power and different specs and different parameters through all the appliances, through the lines and each and every components connected to the network. Still the test is going on. So you can see reactive power limitations, active and reactive power controlling features, like active power limitations, maximum, minimum values, scaling factors are there. This is the more detailed report of the load flow analysis which we have conducted on this system. Likewise, this one click give you detailed report of all the systems and all the tests related to load flow. Now we will do transient stability test. Just let me initialize the conditions, and then I will run simulation for 20 seconds. Let me check the system. Simulation is just started. So this is the graph between rotor angle reference to the machine angle. Some of the generators which we have used in this system, like S5, S12 and S11 generators. You can see The simulation is running for 20 seconds. I will stop it. You can see the graph between different generators which we have used in this system with the reference of machine angle. So these kind of graphs, time-based plots, we can just generate throughout our system. For creating transient cases, this part of the system is short-circuited. This one, this line has been short-circuited. So fault is coming, and we just created the transient stability in high voltage. So these are the plots for that. Now we will see different examples related to wind farm. Just importing that from the database. This is a 15 megawatt wind farm containing 6 wind turbines with fully rated converters connected to 20 kV distribution network. So these are the wind turbines where we already fed the data. You can also feed data by your own. If you have some data, you can just give it to the system. Some global specs standards present. In new project, you can just define your own wind speeds and the generation per unit. You can just have to open your row and you can give it in tabular form to the network or input as a wind turbine. If you have a time series characteristic of active power contribution of wind model, you can just take it from the database of the system if you saved the data, and also time series characteristic of wind turbine in meter per second through a expansion of 1 year. That kind of samples calculations and sample tabular forms readings can be given to the software. So we'll just check harmonic study cases on this system. For that, I have to change it to harmonic cases. This will be executed. We'll check the voltage distortions, harmonic voltages, and harmonic current throughout different buses and different components connected in the bus bar and connected to a network. This is a controller voltage distortion to a controller. This is a graph of harmonic voltages. This is a harmonic current at grid and transformer, and this is the phase shift of transformer. So these kind of some of the study cases just I have gone through to make you understand how this software work and act like, and how the calculations can be seen. And these are the calculations. You can also see the power curves. Just start wind shift. Already fed some standard data to the system. Based upon that, we will analyze the system. This is a plot. Wind speed, losses inside wind farm, and the active power at the converter with the reference on the x-axis wind speed. These are the active and reactive powers. Wind speed versus active power, reactive power, and active power at converter. So these are some graphs which we have plotted, and we can see these graphical analysis through our system while doing analysis. You can see the PQI values and different phase shift values throughout the system. Just got it through a load flow. So this is the basic overview of our software, PowerFactory, and we have some import facilities with these formats, and also we can collaborate this software with the MATLAB, have data on that, we can import it and design network here also and do analysis here also. We have export facility also containing some data format, DGS format, window meta files, bitmap, and different formats including SIM and UCT. So these are some formats. We can export our output files or network diagrams and use it as a simulation. So this is the basic overview of our software. So you can ask questions from us related to this presentation, related to this software. If you have any. Hello. 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 Now you can ask any question related to this software.
అంటే కరెంట్ ఇది ట్రాన్స్ఫార్మర్ MVA ఇవి బస్సెస్ ఫాల్ట్ అనాలిసిస్ లాంటివి ఇలా లేదు సార్ ఫాల్ట్ సింబల్ అయితే లేదు
హలో
ఇవా సార్ ఇక్కడ స్టెబిలిటీ అనాలిసిస్ ఒకటి లోడ్ ట్రాన్సియెంట్ స్టెబిలిటీ సేవ్ క్లియర్ జనరల్ లోడ్ మోడల్ యూజ్ మోడల్ కేస్ ఇన్ఫర్మేషన్ అది ఇచ్చాడు సార్ రన్ మోడ్ లోకి వెళ్తే మనకి ట్రాన్సియెంట్ అనాలిసిస్ లో
హలో
ట్రాన్సియెంట్ అనాలిసిస్ లో సిమ్యులేషన్ ఆప్షన్స్ స్టోరేజ్ లిమిటర్స్ ఐగన్ వాల్యూస్ డైనమిక్ సిమ్యులేటర్ అవుట్పుట్
హలో
ఇక్కడ ఫాల్ట్ లాంటిది ఇక్కడ మై ట్రాన్సియెంట్ కంటిన్యూసీ రన్ ట్రాన్సియెంట్ స్టెబిలిటీ దాంట్లో నేను ప్లాట్స్ లోకి వెళ్ళి మన అన్ని ఇచ్చారు సార్ జనరేటర్ కి జనరేటర్ 1 దాన్ని యాడ్ చేశాను స్పీడ్ ఆఫ్ జనరేటర్ బస్ యాడ్ చేశాను యాడ్ చేసి ట్రాన్సియెంట్ స్టెబిలిటీ రన్ చేయగానే ప్లాట్స్ 1 నుంచి అంటే పర్ యూనిట్ 1 అనుకుంటే 1 నుంచి 1.026 అంటే 0.0026 1500 RPM అనుకుంటే 1.
Sandeep sir, you have any question regarding this software? Hello.
MVAs, megawatts, ఇవన్నీ కూడా యాడ్ చేయొచ్చు.
Vidya ma'am, you have any question for us? Hello. Hello.
LFC करवेगा हमने
LFC करवे सर अभी
Hello. Anyone have any questions related to this presentation? Hello. you can mail us any query. If you have any specific query related to this software, you can just mail us on our email ID. And you can also call us on our phone numbers having registered with you. So please let us know how is the webinar, and also if you have any specific query related to this software. Thank you all for attending this webinar session today. Hello. Yeah, sir, we have facilitating with the preventive control system, and we will assist you after this webinar session. I will call you and we'll discuss about this preventive controlling facilities available with this software. Actually, this time we don't have any pre-loaded example related to that. We definitely will call you after this webinar and we'll discuss about this, and also send some papers presented on this. Any other questions, sir? Okay, sir, I will send you it on your mail, and we'll have discussion on that. I will definitely send you. So thank you everyone for attending this webinar.